Greetings of the day. Welcome to a session of Grade 9 Mathematics. Today, we'll be dealing with Chapter 1, Number System. My dear students, before we actually get into the real concepts of this chapter, let us recall the type of numbers that we have learned in our previous grades, such as natural numbers, whole numbers, integers. We have also learned how to represent these numbers on a number line. In this grade, in chapter 1, we learn about rational numbers, irrational numbers, and a representation of the number line. Along with that, we'll be learning about operations on number lines. Before we proceed with the actual concepts of this chapter, let us have a quick recall of the concepts that we have learned in our previous grades. So first set of collection of numbers that we have learned in our lower grades were natural numbers. Now, how are natural numbers referred to as? They are referred as the counting numbers. For example, 1, 2, 3, 4, 5, 6 and to infinite. Now, the question being asked is, which is the smallest possible natural number? The answer to that would be the number 1. And if someone asks you which is a possible largest natural number, the answer would not be existing because the natural numbers are infinite. The second set of collection of numbers that we have come across in our previous grades are whole numbers. Now, if I include the number 0, I say it again, if I include the number 0 to the set of natural numbers, the newly formed collection of numbers would be known as whole numbers. So I say it again, if we include 0 to the list of natural numbers, then the newly formed collection of numbers will be known as whole numbers. Let us go to the example. If you could see over here, 1, 2, 3, 5 and to infinite numbers are basically my natural numbers. And to that set of natural numbers, if I include the number 0, the newly formed collection of numbers will be known as whole numbers. Now, let us try to understand the next set of numbers, which are referred to as integers. Integers are often referred as collection of negative numbers along with whole numbers. Let us understand it with the given example. Now, the example being given is numbers such as -4, -3, -2, -1, 0, 1, 2, 3 and 4. We know that numbers from 1 to infinite, numbers from 1 to infinite are natural numbers. And if I include the number 0 to the set of natural numbers, I would get my whole numbers. And if we include numbers which are negative, such as -4, -3, -2, -1, to the set of whole numbers, the newly formed set of numbers will be referred to as integers. I say it again, when the negative numbers are added to the collection of whole numbers, the newly formed set of numbers will be known as integers. Let us come to the next set of numbers that we have come across in grade 8, and that is natural rational numbers. Now, how are rational numbers referred as? They are those numbers which can be written in the form of P upon Q. I say it again, they are those numbers which can be written in the form P upon Q, where P and Q are integers, and the second condition is that the value of Q should not be equal to 0. I say it again, the first condition is that the number should be written in the form P upon Q, wherein P and Q are integers. They should be integers and the value of q should be not 0. Let us try to understand it with few. Let us take the example given over here. The first number that has been mentioned over here is a number 2 upon 3. Now, as you can see over here, the value of p is 2 and the value of q is 3. The condition for a number to be rational number is that p and q, which is a numerator and the denominator, have to be integers. And over here, you can see that p, which is 2, and q, which is 3, that is the numerator and the denominator are integers. And the second condition was that the denominator should not be equal to 0. And yes, rightly, you can see over here, the denominator is actually the number 3 and it is not equal to 0. So 2 upon 3 is an example of a rational number. Let us get to the next example. Here, the number being given is minus 4 upon 7. As you could see here, minus 4 is equal to p and the value of q over here is 7. Minus 4 as well as 7 are integers, which satisfies the first condition to become a rational number. And you could see over here that the denominator is 7 and it is not equal to 0. Hence, we can say that even minus 4 upon 7 is a rational number. Let us try with the next number. The number is 5. Now, 5 as such doesn't seem to have a denominator, but we all know that 5 can be written as 5 upon 1, where the value of p is 5 and the value of q is 1. So 5 upon 1, wherein 5 and 1 are integers, and the value of denominator is, as you can see, what's the value of denominator? It is 1 and it is not 0. Hence, 5 upon 1, which is actually 5, is also an example of rational number. Let me ask you a question. How about numbers like 7 upon 0, minus 2 upon 0, and 3 upon 0? Can they be called rational numbers? Let us try to find an answer to this by verifying whether these numbers follow the rules of being a rational number. Now, to be a rational number, what is required? The first rule is that the numerator and the denominator have to be integers. Over here, you can see, yes, 7, which is a numerator, is an integer. Even 0 is an integer. Let's take the next number, minus 2 upon 0. Even this is an integer. 0 is also an integer. How about the next number, wherein the numerator is 3? 3 is also an integer, whereas 0 is also an integer. So it fulfills or satisfies the first rule to become a rational number. Let us try to understand whether does it satisfy the second rule. The second rule to become a rational number is that the value of denominator should not be 0. Whereas you find that here the denominator in each of the case is 0. Hence, since it does not satisfy the rules to become a rational number, we can conclude that 7 upon 0 is not a rational number. Minus 2 upon 0 is also not a rational number. 3 upon 0 is also not a rational number. Now, if they are not rational numbers, then what would be they referred to as? To understand that, let us get to the next type of numbers, which are known as irrational numbers. Now, if we go by the definition of irrational numbers, they are referred to those numbers which cannot be written in the form p upon q. I say it again, which cannot be written in the form p upon q, wherein p and q are integers and q is not equal to 0. In simple words, irrational numbers are those numbers which are not rational. If we get to A few common examples of irrational numbers, they are root 2, root 3, root 5, root 7, and so on. Does that mean that every number with a root would be considered as rational numbers? Let us try to get an answer to that question with the next statement. Here, I put up a question. Is root 4 or root 9 or root 16 an irrational number? Now, we know that root 4 can be solved to get the answer as 2 because square root of 4 is 2. How about square root of 9? Square root of 9 actually gives you the value of 3. How about square root of 16? Square root of 16, when solved, we know that it gives the answer 4. So square root of 4 gives you 2, square root of 9 gives you 3, and square root of 16 gives you answer as 4. And in these cases, 2, 3, 4, which are respectively the answers, these numbers are whole numbers or rational numbers. Hence, you can conclude that root 4 is not a rational number, but it is, yes, you got my statement correctly. It is not an irrational number, but it is a rational number. Even root 9 is also a rational number. Root 16 is also a rational number. So here we conclude that every number that is in the root need not be a irrational number. We have to solve the numbers with the root, and if they happen to be rational, they have to be referred to as the same. Now, coming to the next set of numbers, which are referred to as real numbers. Now, if you go by the definition, real numbers are referred to as collection of all the rational and irrational numbers. Now, let us understand that better with an example. Now, if you could see, the examples given over here are numbers such as root 2, root 3, 7, 8, minus 3, minus 5, 2 upon 5, and minus 5 upon 7. Now, these are collections of real numbers. But if we go and check them individually, root 2 and root 3 are basically irrational numbers. 7 and 8 are rational numbers. Minus 3 and minus 5 are rational numbers. 2 upon 5 and minus 5 upon 7 are also rational numbers. So, as you could see over here, the entire collection of rational and irrational numbers are referred to as real numbers. I hope you all have understood the classification of numbers. Let us quickly recall the type of numbers that we have discussed as of now. The natural numbers, the whole numbers, the integers, the rational numbers, the irrational numbers, and finally the collection of all these numbers which are referred as real numbers. Now, since we have understood the classification of numbers, let us try to apply this knowledge and solve a few questions from the NCERT textbook. Let us solve a few questions from exercise 1.1. The first question given in the textbook is the number 0 a rational number? And if it is so, can it be expressed in the form 0 upon 1? I repeat the question. Is the number 0 a rational number? If it is so, can it be written in the form P upon Q? Now, yes, it is a rational number. Yes, 0 is a rational number because it can be written in the form of P upon Q, because we know that 0 can be written as, say, 0 upon 1 or 0 upon 2 or 0 upon 3 and so on. You can replace the denominator with any integer. except 0. So 0 can be written in the form 0.1, 0.2, 0.3. Since this is in the form of P upon Q, wherein P and Q are integers and Q is not equal to 0, I can conclude that 0 is a rational number. Now, coming to the second question. The second question of the textbook says, find 6 rational numbers between 3 and 4. Now, to get the 6 rational numbers or any set of numbers between any two given rational numbers, there are two methods that you have to follow, two steps that you have to consider. The first step is to get the denominator same for both the numbers. Once you're done with that, the second step is to compare the numerators. Now, we know that 3 can be written as 3 upon 1. 4 can be written as 4 upon 1. Here, the denominators are the same, 1 and 1. And if I follow the method and compare the numerator, I would not get any answer because as such, between 3 and 4, I do not have a natural number. So what I did over here is I multiplied the denominator with 10. So 1 into 10 happens to be 10. Here also, I want the same number or the same answer in the denominator. So here again, 1 was multiplied with 10. The reason is that the denominator has to be same for both the numbers. Now, whatever treatment is given to the denominator, the same treatment has to be given to the numerator also. So, when I multiplied the denominator with 10, the same number is multiplied with the numerator also. The same would apply for 4 upon 1 also, wherein 1 was multiplied with 10, so the numerator also gets multiplied with 10. So now 3 into 10 would be 30 and 1 into 10 would be 10. And if you see over here, 4 into 10 would be 40 and 1 into 10 would be 10. So the answer in the denominator would be the same number. So on solving, we have got 30 upon 10 and on the other side, we have got 40 upon 10. As I said, once you get the denominator common, which is 10 on either side, I could have multiplied the denominator with 100, 1000, any number like 45, 56. All that is required is the denominator have to be the same number on solving it. And then the number which was multiplied to the denominator, the same number has to be multiplied with the numerator. So once I get the same denominator, the next thing that I would do is compare my numerator. So you could see over here, the numerator is 30 and over here, the numerator is 40. Now all that I have to do is find numbers between 30 and 40. So the numbers between 30 and 40 would be 31, 32, 33, 34 till 39. So my answer would be the number between 30 upon 10 and 40 upon 10 are 31 upon 10, 32 upon 10, 33 upon 10, 34 upon 10, 35 upon 10, 36 upon 10, 37 upon 10, 38 upon 10, and 39 upon 10. Now, as is a requirement in the question, I can write any 6 numbers of the above. I say it again, the two methods to get to the answer of such questions are, first, to get the denominator common, and once the denominator is common, all that is required is to compare the numerators. Let us try to understand it with one more example. This is question number 3 given in exercise 1.1 of the NCERT textbook. The question says, write 5 rational numbers between 3 upon 5 and 4 upon 5. So the numbers that we're supposed to deal with is 3 upon 5 and 4 upon 5. Now, here again, I shall compare my denominator, and if you compare your denominator, you'll find that the denominator is 5 in both the cases and it is the same. So the first condition is satisfied. So when that happens, what we do is compare the numerator. Here the numerator is 3 and the other number, the numerator is 4. And if I try to find the numbers between 3 and 4, I don't get any whole number as such. So what I do is follow the same step that I did in the previous sum. I multiply the denominator with 10. So 5 into 10 gives me 50. I need 50 over here also. So again, 5 is multiplied with 10. And then I give the same treatment to the numerators on both the numbers. So if I have multiplied 5 with 20 over here, I would have to multiply 5 with 20 because 5 into 20 is 100. So I have to get 100 in both the denominators. And then that number 20, which was multiplied to the denominator, had to be multiplied with the numerator also. Now, in this case, when 3 gets multiplied with 10, I get 30, and 5 gets multiplied with 10, I get 50. So the number is 30 upon 50. And the other number, when 4 gets multiplied with 10, I get 40. And when 5 gets multiplied with 10, I get 50. Again, I've got my denominators to be equal, the same number. Hence, I can start again comparing the numerators. So between 30 and 40, I will get 31, 32, 33, 34, 35, 36, 37, 38, 39, till 39. So I can write that the numbers between 30 upon 50 and 40 upon 50 are numbers from 31 upon 50, 32 upon 50, 33 upon 50 till 39 upon 50. So as per the requirement in the question, I may write any 5 rational numbers from the given solution that I have obtained. Now, hope you have understood today's session on introduction of number system and how to get different rational numbers between the given two numbers. Let us try to apply our knowledge and understanding and solve a few questions. For your practice, I have given a few questions from the NCERT textbook. This is from NCERT exercise 1.1 and question number 4, wherein you are asked to state whether the given statements are true or false. Now, as you could see over here, the first question is, every natural number is a whole number. You have to answer whether it is true or false. You have to do it on your own so that you could improve your skill. The second question is, every integer is a whole number. The third question is, every rational number is a whole. Since maths is all about improving your skills, so for the betterment of your skills, let us try to practice a few extra sums. Now, after today's session, you have to practice a few questions. The first question is to find 6 rational numbers between 4 upon 7 and 6 upon 7. The second question is to find 5 rational numbers between 2 upon 3 and 4 upon 5. Hope you have understood today's session. Take care of yourself till we meet for the next session. Thank you.